Okay, so 3, 2, 1. Okay, so this is what we did the last time. 3x plus 2y plus z equals to 10. Okay, put your things on the table. Crystal put on the table. Okay. 1x minus 2y plus z equals to 5. Then from here, right? Okay, there are a lot of ways. There are two ways which can go about doing this. Okay, number one, right? We use the GC. Okay, so I can use a GC. Anyone got GC? So this is what we did last time. Remember? Question? Any question? Fair question. Okay. This one, B. You look at A. We look at A first. Okay. So you go to. Remember, we want to take the if any, right, of the two planes. So the keyword is if any. Between any two, either is it line and line, or plane and plane, or line and plane. What's the first thing we can do? Before we check intersection, what can we check for? Whether, ask Shi Yun, what do we check for? Before we check for intersection, what do we check for? Ask Shi. What do we check? The relationship between you and Noel. So between the two planes, between the parallel. Sorry, not Noel, parallel. Okay, so how do I know these two whether parallel or not? I just check whether the scalar multiple. What do I check for to be scalar multiple? Two planes now. Plane got direction vector. Plane have what? Normal vector, right? So I take two planes. I take one. I take two. Correct? Two plane, two normal. How to know whether this normal are parallel? How to know whether the plane are parallel? They don't intersect. How to know whether they don't intersect?
Planes are parallel.
That's so, how do I know if these two planes are parallel?
Then the normal don't intersect.
Normal is a direction vector. Normal can be anywhere, but can be anywhere on the plane. Normal can be anywhere on the plane, right? How do I know if these two planes are parallel? Normal, not normal. Normal, not product, will give you perpendicular. Cross. Any more besides cross?
Cosine.
How do I know if two normal are parallel? How do I know if the plane are parallel? Which one? What is scalar multiple? The normal. So you can see, if I want to focus on the two planes, right? The two planes, okay? I look at the two normal. Now you look at the two normals. If the normals are parallel, it means the plane is parallel, right? Yeah. See, if the normal is parallel, it means the plane is parallel, right? Yeah. So that's what it means. How do I know? How do I find equation? I just find the two normal, check whether they are parallel. That's the first thing you can do, before you even check for line of intersection. So the first thing you do, we check whether they are parallel. Okay. If you're tired, please eat the sweet. Okay, so. Okay, let's say this is my plane 2. Okay. Claire, what is my normal? Plane 2. What's the normal of plane 2? 3 negative 1, 1. Okay. Let's say this is my plane 1. Okay. I ask Hui Qing how to find the normal for what is the normal for plane 1?
Cross product of the two directions.
Very good. Okay. So what I do is to find n1, I need to take m1 multiplied by m2. Okay. Okay. Next question I want to ask is this. Okay, look at this. This is the equation of the plane. There are 3 names. There are 3 forms: parametric form, scalar product form. What's the last one? Vector. Both are vector equation. One is Cartesian, right? Okay, so for plane, right? For plane, vector equation of plane. It can be scalar product form, it can be in parametric form, or it can be in Cartesian form. Cartesian form by itself. Okay, so my question is this. I'm going to ask the student, what form is this? Okay, the person I want to ask is Ian, what form is this? No, you don't say. Okay. Parametric. Okay, good. It's parametric. Huiqing. Oh, okay. So what we do is you take M1, vector product with M2. Okay? Very easy. So -1, 1, 4. Cross product with 1, 2, -1. Okay? Then from here, okay, so you just do a cross product. Okay? Can I all know how to do cross product? Very quickly, the first plane, your normal one, should be 2 of 2, -1, -4. Your second normal vector should be sorry, wrong. I'm so stupid. Okay, so the second should be -3, 3, -1, 1. Can anyone tell me the second normal vector? Second normal vector? 3, -1, 1. Okay, good. So now you observe carefully. Look at the two normal vectors. This is the normal of plane 1. This is the normal of plane 2. Can you tell me is there any line of intersection? No. Why? Because parallel. Oh, okay, good. Okay, also because they are parallel. Okay? That's one thing. So my next question is this. They are parallel, right? Is it okay? So first one is now I show that they are parallel, but I want to show that they are not the same plane. They are not intersecting infinitely many times. So looking at plane 2, observe plane 2. Plane 2, right? The equation looks like that. 3x minus y plus z equals to 3. You can see that 3. If I take 1, 0, 0, right? Can I say the position vector 1, 0, 0 lies on the plane, right? The point lies on the plane. I should say the point lies on the plane, not so I should say 1, 0, 0 lies on plane 2. But does it lie on plane 1? Does it lie on plane 1? Yeah, you can just sub it into plane 1. So what's the equation for plane 1? Okay, remember plane 1 was like this, right? R was equals to 1, 2, -1 plus lambda -1, 1, 4 plus mu 1, 2, -1. Okay, so you just need to sub it in. Okay, just write down, but does not lie on plane 1. That's what I need to write. Okay, in order to show that they have no intersection. Okay, so two things. Number 1, show that the normal is parallel. Number 2, show that they don't have a common point. Okay, I'll leave that. Yes. Can also take the can. Doesn't matter. Either one is fine. Thank you. Okay, alternative, say this is the parametric form, right? You can use the scalar product form of plane 2. Then you sub in, that will be easier. Okay, let me go. How about this? Okay, let me use plane 2. How about I use plane 2? Okay. I use plane 2. Okay, so you see, I use plane 2. I use plane 2, can see, I let this be 1, let mu be 1. Okay? So 1, 2, -1, -1, 1, 4. 1, 2, -1. Okay? Like that. Can I say that 1.2, -1, 1, 2. 1. 2, 1, 2, 5, -1, 4, 2. Can I say 1, 5, 2 lies on plane 2?
Okay, right. So this one, 1, 5, 2 is a position vector. 1, 5, 2 is a point that lies on plane 2. We just check. If I sub in this as 1, I sub in this as 5, I sub in this as 2. Does it lie? So 3 times 1 minus 5 plus 2. Left hand side, this is equals to 3 minus 5 negative 2 equals to 0. The right hand side is equals to 3. Correct? Are they equal? No, right. So does the point 1, 5, 2, are the two planes the same? They're not the same, huh? 一是 okay. 一是 huh? Oh, so all you need to show is for example this way, I just say 1, 5, 2 lies on plane 2 but not on plane 1. Hence, by 1 and 2, plane 1 and plane 2 are parallel and have no intersection. Okay, huh? Sleepy, just eat. Yeah, don't paise. You don't like Mentos, you tell me I buy something else. You want Noel? Huh? Oh, my hearing now this is not very good. Don't know why. Carrot sticks. You rabbit. Okay. Why? But I didn't ban Mentos there. Wait. You laugh and joke a bit, it's okay. 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 Next one, question 8. Find the angle between the two lines. How to find angle between two lines? Cosine. Why is it cosine? Why is it cosine? Why is it must mod? Kellyser. Why must mod? Kellyser man. Huh? Don't know. Oh, okay, angle. Very good. Jia Xuan, why must mod? Why must mod? Stay with me, Jia Xuan. Stay with me. Oh, I'm gonna have heart attack already. I give you first one. Line 1, Okay. I explain very quickly. Line 1. This is A1 plus lambda M1. Jia Xuan, what is A1? Describe A1 to me. What's the meaning? It's a vector that lies on. Okay. Direction between any two vectors. Okay, you see the angle between any two lines. All I need to do, I recognize that. Okay, see where's the angle that we're finding? It's just here. Okay. So it's just like your vectors part 1. Vectors part 1, right? Someone will tell you this. You have A, you have B. Then teacher say both must point out. Both must point out. Okay. Until now, still people never do. So really, don't go and die. Okay. Huh? Which one? So how do I? Okay. So you see this, right? You see this is in part 1. Let me finish part 1. Okay. A. Then what is cosine theta? Cosine theta is A dot B mod A mod B, right? Correct? This one, do I need to mod? No. So in part 1 when they taught you this, right, it could be that the answer also like this. As long as it points out. It could be the answer is negative. Okay, so when in part 1, don't think that the answer cannot be negative. Okay? So a lot of people got this wrong for the. Okay. Yeah. Yes, both can be pointing in. The backside can point each other, the head can point each other, but cannot hit to backside. Yeah, hit to backside very smelly. Okay. Then if it's head to backside, right? Correct? You just extend this vector. Then you look at this one. Okay, you see. Okay, so let me finish. This is part 1. Part 2, right? Part 2, over here, how do we find the angle between these two lines? We just use the two direction vector M1, M2. Okay, so the problem is now cosine theta, right, between these two lines, M1, M2. Okay, M1, M2. This is in vectors part 2. Is this correct? Carissa, is this correct? Jessica, is this correct? What am I short of? Modulus. I must do the modulus. Okay? I must do a modulus. Why do we do the modulus? In case the direction vector is yes. Okay, so angle between two lines. Children, in vectors part 1, right, it's okay because we are very sure, we always make sure the two vectors point out. Vectors part 2, right, part 2, we always define angle between two lines. There can be two ways, you know, children. We can say this, I can say this. Angles between two lines can be this one. It can also be this. Which one do we take? We always take the acute one. Okay, so we don't want this one. How do we make sure that in our calculation we always take the acute one? We always mod. Because why? Cos theta, what? ASTC, right? ASTC. You must make sure your cos theta is positive. Correct? So you want to make sure cos theta is positive, you need to make sure cos theta equals to a mod. Then you make sure it's positive. Then you will always be very sure that you are taking this part. Okay? Can or? Can. So sometimes someone asks, hey teacher, but then how I know the two direction vector point out or point in or head to tail, tail to head? The thing is this, if let's say you got one vector looks like this is M1. Okay? Then maybe the other vector is maybe M2. Then how? What will ensure that you are finding this angle? What will help you to ensure that you're finding this angle? This is line 1. This is line 1. This is line 2. Okay? If I do this right, it looks as though the angle is this, right? It looks as though the angle is this, right? What will ensure that I'm finding this angle? Mod, right? Because modulus will convert this modulus, right? Will cause your so-called here, right? You think about it. When I want this angle, right? If I want this angle, I should be using this vector, right? Correct? What should this vector be? If this is M1, what is this vector? Minus M1. Okay, how do I make sure that I use negative M1? I mod it. Also, modulus will always ensure that you get the acute angle. Okay, but part 1, they never tell you. Part 1, we just tell you, make sure your buttock point each other, your tail point each other. Part 2, direction vector between two lines, you use the modulus to make sure you always get an acute answer, acute angle. Okay? Can all. So, very concept. So, you want to do and practice memorize also can, but very 辛苦 lah. Okay, so first, equation of the two line, I want to find the angle. Line 1, line 2. Okay, line 1 from here, able to get a vector equation? Okay, can anyone tell me for BMQ 8A? Okay, what is the vector equation of this one? 040. 诗云 8A line 1 640 plus 诗云 plus this one was a common mistake, huh? Some students test go and write 6 then becomes look like 0, then minus wrong. Also, this one very important. Make sure you can deceive the whole world, but you cannot deceive yourself. Then your 6 become 4, 2 become 8, so not very good. Okay, just remember write clearly. Okay, lambda 2. What is the equation for lambda 2? Line 2. Ian. Equation for line 2. What's the vector equation for this one? Come on, Ian, come on. Give it to me. 2 minus negative 1. Okay? How to find the equation between these two lines? How to find the angle between these two lines? Cosine theta. Okay. After that, which one do I use? I use the direction vector. Okay, pause. Please go and know. Okay. Okay. square root 2, square root 9. Understand how to get square root 2, square root 9? Okay, huh? Yeah, so this is just eventually the answer will give you 1 over square root 2. Theta equals to 45. This is for 8a. B, okay, I go on. Okay, yeah. 8b. Okay, line 1, 2, 3, negative 1 plus lambda 2, 3, negative. That's how it looks like. Line 2, 4, 1, negative 1 plus mu 2, 1, negative 2. Okay, lambda is real, mu is real. Okay, from here, how to find angle between these two lines? I ask Claire. Dot product, dot. Cosine or sine? Cosine. Cosine theta equals to which two vectors? Very good. Okay, over the modulus of square root 14, square root 9. So answer, you solve, your theta should be 36.7. Okay, can 8C. Okay, 8C, can anyone quickly tell me what is the angle between the two lines? Who has done AC? Okay, line, Megan, what's the angle between the two lines? I give you a hint. Okay, the first line, the direction vector is 1, negative 1. The second line, what's the direction vector? 1, 1. Negative 1. Okay, look at these two. This is the direction vector of line 1. This is the direction vector of line 2. So, from your observation, what do you see? No, I never asked you. I never asked you to answer lah. You are going to think about it. Okay. Megan Fox, come to me. Look like what? Look like the scalar multiple. So your two direction vector now is scalar multiple. What does it mean? They are parallel. Oh, okay. So you can see that line 1, line 2 are parallel. Okay. Can Genius okay. Next one. Sine okay. Children nowadays, the thing is, a lot of us, last time, my time, people just shut up and do. So my time, we just shut up, memorize, don't even bother understand. But your generation is very different. You all need to understand why, because it helps you to study better. So here, why is it sine theta? Okay, I show you all very quickly. You see Let's look at the plane this way. Let's look at the plane this way. Okay, this one is the plane. This one is your plane. Okay, where's the normal? The normal is here. I just anyhow choose one normal. Normal can be anywhere. This is the normal. Now I choose a line. I purposely. Okay, let's say I don't even put a normal first. I choose a line. Stop. Listen. Stupid Ian, listen. Listen. If not, you take T1 today. Then you take T1 the whole week. Okay, listen so this one is your theta, am I right? T2 line, right? So now, you see now I purposely do this. The normal can be anywhere. If I give you a plane, the normal can be anywhere, right? Okay? I purposely put the normal here. Sorry, I use red color to show you it's related to the plane. This is the normal. Okay? So this is theta. Let me ask you, what is this? If this is theta, what is this angle? Can see? 90 minus theta. Okay. Now, what is the direction vector of this line? Let's say I call it M. This one is M, right? Okay. Can you tell me? If I got what is cosine 90 minus theta? Equals to? Using these two. Can you see that if I do the normal vector way, it's like n dot m over mod n mod m, right? Can you see? I use these two vectors. Okay, I use another color. Okay, this one. Can you see? M and these two to find this angle. Cos 90 minus theta is what? It's the same as?
Sine theta.
So sine theta is equals to ensure that we get the acute part, and that's why it is sine. That's why it is sine. Okay? This is the second case, angle between line and plane. First case is what? Angle between line and line. What's the third case? Angle between two planes, right? What's the formula again? Cosine. Why is it cosine?
Because it's a normal.
It's a normal. Why is it cosine? Angle between normal. Can you visualize it?
Yeah.
Can visualize? Jessica can visualize? But can. Sure. Want me to show you? Quick one. Okay, you see. Okay, I just show you very quickly. First plane looks like that. You see, it's very. Once you draw, very common sense. Okay, plane 1. Okay, this is the normal to plane 1. I purposely put here. Okay, plane 2. This one is the angle between the two of them, right? Can? This is the normal to plane 2. I purposely put them intersect. Okay, see. Okay, now okay, I want to show you. Okay, you see. This is 90. What is this? Jia Xuan. The rest don't say. Auto don't say. Jia Xuan, what is this? Okay. Okay, now you observe. You look at this. Okay, you look at this. Kalisa, you look at this. Look at this. Okay, see these two. Look at this. Okay, then my next question is, what is this? Theta. Okay. Now, theta. This is theta. So if you observe, I use these two lines. Can I find theta? Yes, right. That's why it's cosine. Cos theta is just mod of n1 dot n2 over mod of n1 mod of n2. Okay, that's why it's cosine. Okay, you all know good. Make sure you remember. Okay, remember because this one very fundamental. Okay, with that, question 9. Question 9, what do we do? Okay, first one, my line 1 is a 3, 5, negative 4 direction vector. What's my normal vector for the plane? Ask Ian, what's the normal vector for this plane? Zero, 1, 0. Okay, good. How to find? What do I find? How to do? What formula do you use, sine or cosine? Sine. So easily I just put it. Sine theta is first you must let theta denote the angle between. You must write this down. Yeah, must say. Okay. Then sine theta is just direction vector of line 1 dot product with normal vector of plane over the magnitude of the direction vector and the magnitude of the normal vector. Okay, so solving this should give 1 over square root 2. Theta should be equals to 45 degrees. Okay, this is for BMQ 9. Okay. Try to answer question. Actually, you find it very fun. Okay, you answer, you actually learn one. That's why participation helps. Yeah, and don't worry about being judged. Okay. Sometimes I also say the wrong thing, so you just help each other. Okay. Angle now is BMQ 10. Quick one. BMQ 10 for the first plane, normal vector is. Second one is. Very good. So all I need to do, cos theta equals to dot product 2, negative 3, 4, 1, 2, negative 5. Okay, after that, mod 2, negative 3, 4, mod 1, 2, negative 5. Okay, you should get 24 over square root 29, square root 30. Solve. Your theta should be equals to 35.5. Okay, can. So this is BMQ 10.